Shelter provides essential protection from environmental elements such as rain, wind, and extreme temperatures. Shelter is a fundamental need for survival, offering refuge from harsh weather conditions. Shelter serves as a critical defense against potential predators, ensuring safety and security. The need for shelter is a basic instinct, driving humans and animals alike to seek or construct protective structures. The initial step involves identifying a location that offers natural protection from the elements. A suitable location should have readily available natural resources for shelter construction. The chosen site should be relatively level and free from hazards such as falling rocks or unstable trees. Proximity to a water source is advantageous, but should not compromise the shelter's safety and concealment. Branches and large leaves are collected as primary materials for constructing a lean-to. The lean-to structure utilizes collected branches to form a supporting framework. Large leaves are interwoven to create a weather-resistant covering for the lean-to. The completed lean-to provides basic shelter, utilizing natural materials found in the forest environment. The A-frame structure is constructed using sturdy branches found in the surrounding environment. Branches of sufficient length and thickness are selected to provide structural support. The branches are arranged in an A shape, forming the primary support structure. The stability of the A-frame depends on the secure connection at the apex. This simple structure provides a basic framework for shelter construction. Layering leaves and smaller branches can create a windbreak. Windbreaks reduce wind speed by creating a barrier. The density and height of the windbreak affect its efficiency. Windbreaks can protect areas from strong winds. Stones are used to reinforce the base of a lean-to structure. Reinforcement prevents slippage and enhances structural stability. Proper stone placement distributes weight and secures the lean-to against external forces. Selecting appropriate stones is crucial for effective reinforcement. The stone reinforcement method is a fundamental technique in wilderness survival. A stable base ensures the lean-to can withstand environmental conditions. Tall grasses and reeds are identifiable by their height and stalk structure. Suitable thatching grasses possess strong, flexible stalks for weaving and durability. The density and thickness of the grass influence its insulating properties when used for thatching. Visual inspection can reveal signs of rot or pest damage, indicating unsuitability for thatching. The length of the grass blades affects the overlap and weather resistance of the thatched roof. Certain grass species are naturally more water-resistant due to their waxy cuticle. Grasses are cut and harvested from the grassland environment. Cut grasses are bundled together to form manageable units for transport. Bundled grasses serve as a primary building material for constructing shelters. Grass shelters provide protection from the elements and contribute to environmental adaptation. Grasses are woven together to form panels. These panels serve as the building blocks for a simple hut structure. The weaving process involves interlacing individual strands of grass to create a cohesive surface. Grass panels provide insulation and protection from the elements. The hut structure provides a basic form of shelter in a grassland environment. This construction method utilizes readily available natural resources for sustainable building. A circular base is essential for the structural integrity of a domed grass hut. The base provides a stable foundation, distributing the weight of the dome evenly. Constructing the base involves compacting earth or arranging stones in a precise circular pattern. The diameter of the circular base determines the overall size and interior space of the hut. Properly preparing the ground ensures the base remains level and prevents future structural issues. The circular design maximizes space efficiency and structural stability for a domed dwelling. Grass panels are attached to a frame structure. The grass panels are overlapped to enhance weather resistance. The frame provides structural support for the grass panels. Overlapping grass panels create a barrier against the elements. The attachment process ensures secure and stable panel integration. The completed structure demonstrates a weather-resistant design. An entrance is created to provide access to an enclosed space. The entrance is small to limit exposure and maintain security. Woven grass mats are used to reinforce the entrance structure. Reinforcement provides structural integrity and durability to the entrance. The grass mats are strategically placed to strengthen vulnerable points. Natural materials are utilized for sustainable and eco-friendly construction. Natural caves and rock overhangs can provide shelter from the elements. Caves offer protection from rain, wind, and extreme temperatures. The structural integrity of the cave or overhang is crucial for safe shelter. The depth and size of the cave determine the level of protection it offers. Vegetation around the cave entrance can indicate the presence of a stable microclimate. Clearing debris is essential for preparing a cave floor for habitation. The process involves removing stones and organic matter to create a level surface. A smooth, debris-free floor enhances safety and comfort within the cave dwelling. Preparing the cave floor is a foundational step in establishing a habitable space. Stones can be used to block or narrow a cave entrance. Blocking the cave entrance provides added protection. Narrowing the entrance enhances defense capabilities. Strategic stone placement is crucial for effective blocking. A partially blocked entrance offers a balance between security and accessibility. Building a fire near a cave entrance serves to deter animals. The fire provides warmth, increasing the ambient temperature near the cave. Smoke from the fire acts as a visual deterrent to approaching wildlife. The light emitted by the fire creates a zone of visibility, alerting to potential threats. Maintaining a fire requires a continuous supply of fuel, such as wood. The controlled fire provides a safer alternative to the uncontrolled environment outside the cave. Clay and mud are sourced directly from the riverbank. Riverbank soil provides essential raw materials for construction. The process involves extracting, collecting, and transporting clay and mud. The riverbank environment naturally replenishes clay and mud deposits over time. Sourcing from the riverbank offers a readily available and cost-effective construction resource. Mud bricks are created by mixing clay with straw or grasses. The addition of straw or grasses provides structural integrity to the mud brick. The mixture is then pressed into molds to form the shape of the brick. Sun drying hardens the mud bricks, making them suitable for construction. Mud bricks provide a readily available and sustainable building material in many regions. The combination of clay and straw creates a composite material suitable for building. Mud bricks are sun-dried to harden them for building purposes. The sun's heat evaporates moisture from the mud bricks, increasing their structural integrity. Sun-drying is a natural and cost-effective method for hardening mud bricks. The duration of sun-drying depends on environmental factors such as temperature and humidity. Hardened mud bricks provide a durable and sustainable building material. Mud bricks are constructed from dried mud, providing a sustainable building material. The process involves shaping mud into bricks and allowing them to dry naturally in the sunday. Low walls can be constructed using dried mud bricks, offering a simple and cost-effective building solution. The structural integrity of mud brick walls depends on the composition of the mud and the drying process. Mud brick construction is an environmentally friendly building method, utilizing local resources. Mud can be utilized as a mortar to effectively seal gaps between bricks. The use of mud as mortar provides a readily available and cost-effective solution for construction. Mud mortar's binding properties are essential for creating stable brick structures. The durability of mud mortar depends on environmental conditions, such as moisture and temperature. Proper mud preparation is crucial for achieving optimal mortar strength and adhesion. Mud mortar's environmental impact is significantly lower compared to cement-based alternatives. Mud bricks provide a durable material for constructing permanent shelters. The dome structure offers enhanced stability and efficient use of materials. Construction involves layering mud bricks to form a self-supporting dome shape. The interlocking arrangement of bricks maximizes structural strength. A mud brick dome provides a sustainable and cost-effective shelter solution. Various sizes and shapes of stones and rocks are collected from mountainous terrain. The collected stones exhibit diverse geological compositions and textures. Stone and rock collection involves identifying and categorizing based on physical properties. The process of collecting stones can be used for geological study and analysis. Collected stones and rocks provide insights into the Earth's geological history and formation processes. Circular or semicircular stone walls provide effective wind protection in exposed environments. The curved design of the wall minimizes wind pressure and maximizes structural stability. Stone walls offer a durable and sustainable solution for creating sheltered areas in natural settings. The wall's construction utilizes locally sourced materials, reducing environmental impact. Smaller stones are used to fill gaps in the wall. Filling gaps with smaller stones enhances the wall's overall stability. Interlocking stones create a more cohesive and durable structure. The use of smaller stones optimizes the wall's structural integrity. Animal hides serve as a readily available roofing material in mountainous environments. Large leaves can be used to create a temporary, waterproof roof structure. A stone wall provides a stable base for constructing a makeshift shelter. Combining natural materials with existing structures enhances shelter construction efficiency. The makeshift roof provides protection from the elements in a rugged environment. Driftwood is wood that has been washed onto a shore or beach of a sea, lake, or river by the action of winds, tides, or waves. Seaweed refers to various species of macroscopic, multicellular, marine algae. Both driftwood and seaweed are natural coastal resources. Gathering driftwood and seaweed can be a sustainable practice when done responsibly. Driftwood logs are used as a natural and readily available material for constructing frames. The frame construction utilizes the inherent strength and stability of the driftwood. The interlocking of driftwood pieces creates a robust and sustainable framework. The frame provides a foundation for various coastal structures and installations. The use of driftwood minimizes environmental impact by repurposing natural debris. The driftwood frame blends harmoniously with the coastal landscape, creating a natural aesthetic. Seaweed can be used as a natural insulating material. Packing seaweed around a frame provides insulation against temperature variations. Seaweed acts as a natural weatherproofing agent, protecting structures from the elements. The density and arrangement of seaweed contribute to its effectiveness as insulation and weatherproofing. Coastal structures require reinforcement to withstand wind forces. Stones are strategically placed to enhance structural integrity against coastal winds. Reinforcement distributes wind load, preventing structural failure. Proper stone placement is crucial for effective wind resistance. Reinforced coastal structures protect against erosion and damage from strong winds. A raised platform shelter provides protection from ground-level threats such as flooding. Elevating a shelter can prevent encounters with ground-based predators. The platform is constructed using readily available materials such as branches and logs. Securing the platform's base with sturdy supports ensures stability and prevents collapse. A woven floor provides a comfortable and secure surface within the raised shelter. Raised shelters offer a dry and secure refuge in wet or swampy environments. The selection of strong, straight trees is crucial for providing reliable support. Straight trees ensure even weight distribution, minimizing stress points. Selecting robust trees prevents structural failure under load. Proper tree selection enhances the overall stability and longevity of the structure. The diameter and height of the tree contribute to its suitability as a support post. Interweaving branches forms the foundational structure of the platform. Vines are used to bind and secure the branch structure, enhancing stability. The interwoven structure distributes weight evenly across the platform. This construction method utilizes natural materials for a sustainable and adaptable platform. A roof structure provides added protection over a platform. The roof structure is designed to shield the platform from rain and sunday. Simple materials such as branches and leaves can be used to construct a protective roof. The angle of the roof helps to effectively drain rainwater. A well-constructed roof enhances the utility and durability of the platform. Wattle and daub construction involves creating a woven lattice of wooden strips, called wattle. Daub, a mixture of clay, soil, sand, animal dung, and straw, is applied to the wattle. The daub fills the gaps in the wattle, creating a solid and insulated wall. The mixture is left to dry and harden, providing structural integrity and weather resistance. Wattle and daub is a simple and readily available construction method using natural materials. This method provides a sustainable and cost-effective shelter solution. Wattle construction involves weaving branches and twigs together. The woven branches form a framework that provides structural integrity. Different weaving patterns can be used to adjust the density and strength of the wattle. Wattle frameworks serve as a foundation for walls, fences, and other structures. The initial step involves preparing a mixture consisting of mud, clay, and straw. This mixture is then applied to the wattle framework. The mud, clay, and straw mixture provides structural reinforcement to the wattle framework. The application process ensures a cohesive bond between the wattle and the mixture. This process contributes to the overall durability and weather resistance of the structure. Mud daub is smoothed to create an even surface. The drying process allows the mud daub to harden and gain structural integrity. Hardened mud daub provides a durable and protective layer. The composition of mud daub affects its drying and hardening properties. Digging a pit or trench in the sand can create a subterranean shelter. The sand acts as insulation, maintaining a more stable temperature inside the shelter. Subterranean shelters offer protection from the sun's intense heat. The depth of the pit affects the shelter's temperature regulation. Sand trenches provide a simple and effective method for creating temporary refuge. Branches and leaves can be used to construct a makeshift roof over a pit. The roof provides shade and protection from the sun's intense heat. The structure reduces direct sunlight exposure within the pit. This improvised shelter helps to maintain a cooler temperature inside the pit. The natural materials effectively diffuse sunlight, creating a more comfortable environment. Covering a roof with sand and earth provides insulation against solar heat gain. The thermal mass of earth and sand helps to regulate indoor temperature fluctuations. This insulation method reduces the need for active cooling systems. Conserving energy. Using natural materials like sand and earth offers a sustainable and eco-friendly building solution. Subterranean shelters offer a natural method of temperature regulation in extreme climates. The Earth's consistent temperature below the surface provides insulation against both heat and cold. By leveraging the Earth's thermal mass, subterranean shelters reduce the need for active heating and cooling systems. This passive temperature regulation results in significant energy savings and reduced environmental impact. A snow cave provides temporary shelter in cold, snowy environments. The primary function of a snow cave is to insulate against external temperatures. Snow caves utilize the insulating properties of snow to maintain a relatively stable internal temperature. The construction of a snow cave involves excavating a cavity into a snowdrift, ensuring a small entrance to minimize heat loss. Snow caves are effective for short-term survival situations due to their simplicity and reliance on readily available materials. A snowdrift provides a natural shelter from wind and cold. Carving a space in a snowdrift creates an immediate, temporary refuge. The density of the snow affects the ease and stability of the carved space. Snowbanks offer a more substantial structure for creating a snow shelter. The depth and consistency of the snowbank determine the size and durability of the shelter. Properly constructed snow shelters provide insulation and protection from the elements. Adequate ventilation is crucial to prevent the accumulation of carbon dioxide. Carbon dioxide buildup can occur in enclosed spaces with limited air exchange. Ventilation systems facilitate the removal of carbon dioxide, maintaining safe air quality. Regular monitoring of carbon dioxide levels ensures a safe and healthy indoor environment. Snow caves provide insulation by trapping air, which acts as a barrier against the cold. The enclosed space within a snow cave minimizes heat loss through convection and radiation. Snow's porous structure contains numerous air pockets, significantly reducing thermal conductivity. The insulating properties of snow caves allow for a stable internal temperature, even in extreme external conditions. Animal hides can be used as a primary material for constructing shelters in outdoor environments. Hides provide protection from the elements, offering insulation and resistance to wind and rain. The process involves stretching and securing the hides over a frame made of branches or wooden poles. Proper preparation and treatment of the hides are essential for durability and longevity of the shelter. The size and shape of the shelter can be adjusted based on the number of hides available and the desired occupancy. Animal hide shelters represent a traditional and sustainable approach to creating temporary or semi-permanent dwellings. Animal hides are prepared by stretching them to prevent shrinkage and maintain shape during the drying process. Stretching ensures the hide dries evenly, preventing wrinkles and maintaining a consistent thickness. Drying animal hides removes moisture, which prevents decay and preserves the material for later use. The drying process typically involves suspending the stretched hide in a well-ventilated area. Different stretching and drying techniques can be employed based on the type of animal hide and desired end product. Properly prepared hides can be used for clothing, shelter, tools, and other essential items. Hides are sewn together to form larger panels. The sewing process involves creating a seam that joins the hides securely. Larger panels are created by connecting multiple hides. The resulting panels can be used for shelter or clothing. Sewing hides together increases the size and functionality of the material. Hides can be used as a covering for a frame structure. Hides can also serve as a windbreak. Frame structures provide a basic shelter. Windbreaks offer protection from harsh weather conditions. Natural materials are used to construct hides. Hides and frames provide protection in outdoor environments. A yurt-like structure is constructed using flexible branches to form a circular frame. Hides are stretched and secured over the branch frame, providing an outer layer for the structure. The combination of branches and hides creates a simple, portable shelter. This construction method utilizes readily available natural resources for shelter creation. The process involves bending branches to form a circular frame. The branches are carefully shaped to create a structurally sound circular form. The completed circular frame provides a stable boundary. The circular frame can be used for various purposes. Hides can be used to cover the frame. Woven grass mats provide another option for covering frames. These coverings offer concealment and protection within the environment. The texture and color of the covering should match the surrounding environment. Ropes or vines are used to secure a structure. Securing the structure enhances its stability against external forces. Different knot types can be used to optimize the strength and reliability of the rope bindings. The tension applied to the ropes must be carefully balanced to avoid structural stress. Natural materials, such as vines, can provide a sustainable alternative to synthetic ropes. Properly secured structures are more resistant to environmental factors like wind and rain. A raft shelter provides temporary protection on the water. The primary function is to shield occupants from sun and rain. Raft shelters are typically constructed using readily available materials. The structural integrity relies on secure lashing techniques. Raft shelters offer a mobile and adaptable solution for river travel. Logs are gathered and aligned parallel to each other to form the base of the floating platform. Ropes or vines are used to tightly bind the logs together, securing them in place. Knots are strategically tied to ensure the structural integrity of the log raft. The completed log platform provides a buoyant surface for transportation or crossing water. The size and number of logs determine the platform's overall weight capacity and stability. The platform's buoyancy is based on the principle of displacement, where the logs displace an amount of water equal to their weight. Branches provide a structural framework for a basic shelter. Leaves offer a natural, readily available material for weather protection. The combination of branches and leaves creates a simple, effective shelter. Shelters provide protection from environmental elements. A raft shelter can be utilized as a stable platform for fishing activities. The raft shelter provides a means of transportation across bodies of water. Raft shelters facilitate access to fishing locations otherwise unreachable from the riverbank. The design of the raft shelter allows for the transport of fishing gear and supplies. Raft shelters offer a mobile and adaptable solution for river-based transportation and resource gathering. A natural rock overhang can provide immediate shelter with minimal modification. The overhang's depth and height determine the level of protection from the elements. Loose rocks and unstable surfaces must be cleared to create a safe shelter space. Adding natural materials like branches and leaves can enhance the shelter's insulation and concealment. The overhang's orientation relative to prevailing winds and sunlight affects its suitability as a shelter. Regularly inspect the overhang for signs of instability to ensure continued safety. Overhang stability is enhanced by reinforcing it with additional stones. The process of reinforcement involves strategically positioning stones to counteract gravitational forces. Adding stones increases the structural integrity of the overhang, preventing potential collapse. The size and placement of stones are critical factors in achieving optimal reinforcement. Reinforcement techniques ensure the long-term durability and safety of the overhang structure. Shelter construction involves strategically using available materials to block wind. Effective shelter design prevents rain from entering the interior space. Natural materials like branches, leaves, and stones can be used to create a protective barrier. Proper layering and overlapping of materials are crucial for effective wind and rain protection. Shell middens are accumulations of discarded shells, forming a protective structure. Discarded shells provide readily available building material in coastal environments. Shell-midden shelters utilize the natural insulating properties of shells. Building a shell-midden shelter involves layering and compacting discarded shells to create a stable structure. Shells can be strategically piled to construct walls. Shell walls serve as effective windbreaks in coastal environments. The density and height of the shell wall determine its wind-blocking efficiency. Shell walls provide a natural and sustainable method of wind protection. The interlocking structure of shells enhances the stability of the wall. Shell walls can be adapted to various heights and lengths to suit specific wind protection needs. Shell middens serve as a natural reservoir of calcium and other essential nutrients. The decomposition of shells within middens releases calcium, enriching the surrounding soil. Plants and organisms benefit from the calcium and nutrients released from shell middens. Shell middens provide a sustainable, natural source of soil enrichment in coastal ecosystems. Camouflaged shelters blend seamlessly with the natural forest environment. Natural materials like leaves, branches, and soil are used to construct and conceal the shelter. Effective camouflage reduces the shelter's visibility, making it difficult to detect. The shelter's design mimics the patterns and colors of the surrounding forest. Camouflaging shelters involves covering them with natural materials. Leaves provide a layer of visual disguise, disrupting the shelter's shape. Branches add structural complexity and further break up the shelter's outline. Moss creates a soft, textured surface that mimics the surrounding environment. The goal is to make the shelter indistinguishable from the natural forest environment. Camouflage is a crucial survival strategy that allows animals to blend seamlessly with their environment. Effective camouflage helps prey avoid detection by predators, increasing their chances of survival. Coloration, patterns, and textures are key elements of camouflage, enabling animals to match their surroundings. The effectiveness of camouflage depends on the visual acuity of the predator and the specific environment. A windbreak is a barrier used to reduce wind speed and protect an area from the effects of wind. Woven grass mats can be used as a simple and effective material for constructing a windbreak. The density and height of the windbreak determine its effectiveness in reducing wind velocity. Windbreaks protect crops, reduce soil erosion, and provide shelter for animals. Proper placement of a windbreak is crucial for maximizing its protective benefits. Windbreaks are strategically angled to deflect prevailing winds. Deflecting wind reduces wind speed and its direct impact on the protected area. Angled windbreaks create a zone of reduced wind pressure behind them. The angle of the windbreak optimizes the area of protection from strong winds. Proper angling of windbreaks minimizes soil erosion and protects crops. Windbreak angling maximizes the benefits of wind deflection for environmental and agricultural purposes. Windbreaks reduce wind speed, thereby decreasing wind chill. Lower wind speeds result in a higher effective temperature experienced by individuals. Windbreaks create a sheltered microclimate with reduced convective heat loss. The effectiveness of a windbreak depends on its height, density, and length. Dense windbreaks provide greater wind reduction, but may create turbulence. Windbreaks can significantly improve comfort and reduce energy consumption in exposed environments. A fish trap shelter is constructed using natural materials found along the riverbank. The shelter's design allows fish to enter, but makes it difficult for them to escape. Strategic placement of the trap in the river maximizes the chance of catching fish. The fish trap shelter provides a sustainable method for catching fish in a river environment. Regular maintenance ensures the fish trap remains effective and environmentally friendly. A small shelter is constructed near the fish trap for monitoring purposes. The shelter provides a vantage point for observing the fish trap's effectiveness. The structure offers protection from the elements while monitoring the fish trap. Regular monitoring ensures timely maintenance and prevents potential damage to the fish trap. The shelter's location allows for quick access to the fish trap for harvesting and upkeep. Symbiotic relationships exist where one organism provides shelter for another. In return for shelter, the sheltered organism may provide a food source for the other. This exchange represents a mutually beneficial symbiotic relationship. Such relationships enhance the survival and prosperity of both species within the ecosystem. Sustainable shelter practices aim to minimize environmental impact. Using locally sourced, Renewable materials reduces the carbon footprint of construction. Passive heating and cooling designs reduce energy consumption for climate control. Water conservation systems, such as rainwater harvesting, ensure efficient resource management. Waste reduction and recycling practices minimize pollution and resource depletion. Shelter construction techniques are critical for survival in diverse outdoor environments. The primary function of a survival shelter is to provide protection from the elements. Natural materials such as branches, leaves, and snow can be utilized for shelter construction. Different environments necessitate different shelter designs for optimal protection. Proper shelter construction significantly increases the chances of survival in emergency situations. Please subscribe to the channel and hit the notification bell so that you will be updated for more videos.